Hey, it's Mr. Saltano, and this lesson is going to be on conservation of matter. So conservation of matter. Firstly, the root word of conservation is conserve, right? So to conserve means to preserve, to maintain, or to try to keep the same. So you're going to want to focus on that, essentially. That keep the same is what we're really looking at. So this conservation of matter principle essentially says that matter cannot be created or destroyed, it can only be rearranged. So we're going to go, this whole video is going to be discussing that. So you can't bring in any new matter, and you also can never destroy matter. You can only take the matter that already exists and rearrange it to make something new. So how does this apply to a chemical reaction? Well, whatever matter you have at the start of a chemical reaction, at the end of the reaction, even though you'll have a new substance, the same building blocks that were in the beginning of that reaction will still be there, just in a completely new form. A chemical reaction is like a transformation of the same pieces that you started with, essentially. So I wanted to show you a video first to kind of help you, a video that we've all seen, one of the greatest movies of all time, to help show you kind of what I mean by this.
Everything you see exists together in a delicate balance. As king, you need to understand that balance and respect all the creatures, from the crawling ant to the leaping antelope.
But Dad, don't we eat the antelope?
Yes, Simba, but let me explain. When we die, our bodies become the grass, and the antelope eat the grass. And so, we are all connected in the great circle of life.
So as you just saw in the video, that the same principle applies in The Lion King and in the real world, where all of the matter that was used to make up a lion, for example, is then broken down to make the grass, which is then eaten by other animals. You're still using that same matter that you began with, it's just transforming into something else. You have the same exact building blocks present. Another example, you can kind of see the same thing here. This is called the carbon cycle that you would have gone over in biology. And so, for example, we as humans, or also cows, produce carbon dioxide, right? And then that carbon dioxide is then taken in by plants, and then the carbon from the carbon dioxide is used to create the structure of the plants. And then so that's just another example of the carbon is cycling all the way throughout. There's different chemicals that are made of carbon. The atoms are just rearranged, but you're using the same carbon atoms for all of these different things shown in the picture, whether it's through the carbon in the soil or in the plants or in the cow or us or in the carbon dioxide in the air. Okay. So this also has important ramifications from a mass perspective. So for example, matter is conserved is the whole point of what we're saying, right? But a requirement of matter is that it has to have volume and it has to have mass. Now, because we say matter is conserved, then we can also say that mass is conserved. So some people will actually refer to this law as the conservation of mass instead of conservation of matter. It's still the same principle, essentially. Now what that means is that the total mass before a reaction will be the same as the total mass after the reaction. So for example, here we have a chemical, sodium sulfate, and another chemical inside this test tube, calcium chloride. And then here we mix them together, we let the chemicals come together. Now we've made calcium sulfate and sodium chloride. We've made a completely new chemicals, but we use exactly the same atoms involved in both in the whole thing. In the chemical reaction, we use the same exact atoms. We just rearrange them to make two completely different products, but we use the same exact atoms. So we didn't lose any mass. If this is actually a balance that these both flasks are sitting on, here we have 300.23 grams, and here we have 300.23 grams again. So we didn't lose any mass involved in that process because it's conserved. And so I wanted to show you a clip essentially that shows you a little bit of a better perspective how to see this.
The law of conservation of mass states that in a chemical change, matter is neither created nor destroyed. It is only rearranged. For example, let's place 5 zinc and 5 sulfur atoms onto the two sides of a pan balance. The two sides balance because the contents of each pan are identical. Consider the reaction of zinc with sulfur atoms on one side of the balance to form zinc sulfide. 5 zinc atoms will react with 5 sulfur atoms with a tremendous release of energy to form 5 zinc sulfide molecules. The two sides still exactly balance. The total number of zinc and sulfur atoms on each side are still identical, demonstrating the law of conservation of mass.
Okay, so now that we've seen that, we should have a good understanding of this reaction we're looking at here. This is hydrogen gas and oxygen gas, and if you combine hydrogen gas and oxygen gas, if they collide with each other, they will actually produce water, H2O. So what we're looking at here is one molecule of hydrogen with another molecule of hydrogen, and we react that with one molecule of oxygen, and then we get 2 molecules of water. Now, this is also demonstrating, see, we have a total of 4 hydrogen atoms. On this side, we also have 4 hydrogen atoms. And on here, we have 2 oxygen atoms. On this side, we also have 2 oxygen atoms again. We didn't lose anything. And we also didn't make anything. We just took the same building blocks we started with, those same atoms, and we made a new substance. So we made, water is completely different from hydrogen or oxygen, right? But the building blocks used are the same. It's just that when they combine in different ways, they act completely differently. And so we have a couple of elements here that combine to make a compound which behaves very differently. So the thing that I think is so cool about this is that the conservation of matter principle says that matter cannot be created or destroyed, only rearranged. That means that all the matter that we have today was the same exact matter that was there when the universe first started. The instant the universe started, the same matter is here today that was there then. It's just been rearranged to form different things. It's been rearranged to form all the different creatures on Earth, for example, just as a very small example. And so that's what's so cool about this principle. So that's it for conservation of matter and conservation of mass. Thanks for watching. And remember, chemistry is everywhere.